Engine specifications, Mercedes-Benz C230 Kompressor, M111.981. Engine code, M111.981. Displacement, 2.3 liters, 2,295 cubic centimeters. Configuration, inline 4, DOHC, dual overhead cam. Fuel type, gasoline. Compression ratio, 9.0:1. Induction, supercharged, via Eaton supercharger. Performance figures. Maximum horsepower, approximately 193 HP, 143 kilowatts, at 5,500 RPM. Maximum torque, approximately 280 nanometers, 206 lb-ft, at 3,000 RPM. Top speed, around 230 km per hour, 143 miles per hour, depending on conditions and model year. 0 to 60 miles per hour, 0 to 100 km per hour, approximately 7.2 seconds. Supercharger. Supercharger type, Eaton M45 supercharger, a positive displacement type that forces more air into the engine for better combustion and increased performance. Boost pressure, 0.8 to 0.9 bar, 12 to 13 psi, of boost, contributing to the engine's enhanced power output. Fuel system. Fuel injection, electronic fuel injection, EFI, system. Fuel system management, Bosch Motronic Me 2.1 or 2.8, a sophisticated system that controls fuel delivery and engine performance based on various sensor inputs. Dimensions. Bore x stroke, 88.0 mm x 82.0 mm. Total engine length, approximately 640 mm. Total engine width, approximately 640 mm. Total engine height, approximately 635 mm. Weight, around 150 to 170 kilograms, depending on the configuration and additional components. Cooling. Cooling system, liquid-cooled with an aluminum alloy engine block and cylinder head, as well as an integrated oil cooler. Radiator, front-mounted, with cooling lines running to both the engine and transmission for optimal temperature regulation. Timing system. Valve train, DOHC, double overhead cams haft, 4 valves per cylinder. Timing chain, the engine utilizes a timing chain that connects the crankshaft to the cams hafts, ensuring proper synchronization of the intake and exhaust valve operation. VVT, variable valve timing, the engine uses a variable timing system to optimize intake and exhaust valve timing for better performance and fuel efficiency. Lubrication system. Oil capacity, approximately 4.5 to 5.0 liters, depending on the model year. Oil filter, standard spin-on filter located at the side of the engine. Oil pump, gear-driven oil pump to provide proper oil circulation throughout the engine, ensuring proper lubrication of moving parts. Transmission compatibility. Transmission options. 5-speed manual transmission, standard on some models. 5-speed automatic transmission, optional, 722.6 series transmission. Drivetrain layout, front engine, rear-wheel drive, RWD, providing a balanced driving experience with good handling and power delivery. Exhaust system. Exhaust manifold, cast iron or stainless steel, designed to withstand the high temperatures generated by the supercharged engine. Catalytic converter, a standard 3-way catalytic converter for emissions reduction. Exhaust type, dual exhaust system with twin tailpipes, designed to reduce back pressure and enhance engine performance. Fuel economy. City, approximately 20 to 22 mpg, miles per gallon. Highway, approximately 28 to 30 mpg, miles per gallon. Combined, around 24 to 26 mpg, miles per gallon. Additional features and performance enhancements. Supercharger functionality, the Eaton M45 supercharger is a significant component of the C230 compressor engine. It uses a gear-driven mechanism that forces air into the engine, increasing the intake pressure and thus improving the engine's combustion efficiency. This allows the engine to produce more power without the need for additional fuel consumption, resulting in a better power-to-weight ratio. Compression and turbo-like response, the engine's 9.0:1 compression ratio is designed to accommodate the forced induction provided by the supercharger. This ensures that the engine can handle the added pressure from the compressed air, which increases overall performance while still maintaining reliability. Suspension and handling, the C230 compressor comes with a suspension system tuned for sportier handling characteristics. The car uses an independent front suspension, McPherson struts, and an independent rear suspension with a multi-link design, allowing for better cornering and a more responsive driving experience. Cooling and maintenance, because the engine is supercharged, it generates more heat than a naturally aspirated engine. The C230 compressor uses an efficient cooling system, which includes an intercooler to cool the air coming from the supercharger before it enters the engine. This ensures optimal engine performance and longevity. Performance tuning and modifications. Aftermarket modifications, many enthusiasts modify the C230 compressor with upgraded superchargers, larger intercoolers, and performance exhaust systems to increase power output and enhance driving dynamics. Chip tuning, the car's ECU can be remapped for higher performance, which can lead to increases in power and torque output, as well as improved throttle response. Supercharger pulley upgrades, a common modification involves changing the supercharger pulley to increase boost pressure, leading to higher power levels. However, this should be done with caution to avoid stressing the engine components. Common issues and maintenance tips. Supercharger maintenance. Over time, the supercharger may require service, including oil changes in the Eaton unit and checks for signs of wear such as abnormal noises or performance issues. Fuel system. Ensure regular fuel system cleaning, including the fuel injectors, to avoid performance loss due to clogging. Cooling system. Given the extra heat generated by the supercharger, it's essential to keep an eye on the cooling system, ensuring there are no leaks and the coolant is at the proper levels. The Mercedes-Benz C230 compressor offers a 2.3-liter supercharged inline-4 engine that produces about 193 HP and 280 nanometers of torque. It features a sophisticated Eaton supercharger, which contributes to the vehicle's peppy performance, providing a satisfying balance between efficiency and power. Regular maintenance of the supercharger, cooling system, and fuel system is essential for keeping the engine running smoothly. This engine is well regarded for its reliability and performance but does require careful attention to ensure it continues to run at its best. A detailed and systematic approach to removing and repairing the engine in a 1999 Mercedes-Benz C320 compressor. Engine code, M111.981. Configuration, inline 4, 4-cylinder, 16-valve, double overhead cams Haft, DOHC, design. The engine configuration is inline 4, meaning the 4 cylinders are arranged in a straight line along the engine block. This layout is simpler, cost-effective, and helps reduce vibrations. The DOHC design means that there are 2 cams Hafts at the top of the engine, one for the intake valves and one for the exhaust valves. The advantage of DOHC over SOHC, single overhead cams Haft, is better airflow and valve control, allowing higher performance and better fuel efficiency. Block material, aluminum alloy. The use of aluminum alloy helps in reducing weight, ensuring the engine is lighter and more efficient without compromising strength and durability. Cylinder head, aluminum alloy with DOHC, 4 valves per cylinder. The cylinder head is where the intake and exhaust valves are located, and it is bolted to the top of the engine block. It controls the flow of air and fuel into the cylinders and exhaust gases out. The 4 valves per cylinder enhance engine breathing, allowing more air and fuel to enter and exit the cylinder, thus improving power output. Displacement, 2.3 L, 2,295 cubic centimeters. Displacement refers to the total volume of air/fuel mixture an engine can process in a single cycle. Larger displacement allows more power because it enables more fuel to be burned. Supercharging system. Supercharger type, Eaton M45, a positive displacement supercharger. The Eaton M45 supercharger is a Roots-type positive displacement supercharger. It increases air pressure, boost, forcing more air into the engine's intake manifold. More air means more oxygen for combustion, which results in more power from the same amount of fuel. The Eaton M45 is gear-driven, meaning it's connected to the engine via gears, ensuring that the supercharger speed is synchronized with the engine speed. Boost pressure, 0.8 to 0.9 bar, 12 to 13 psi. Boost pressure refers to the increase in intake air pressure compared to atmospheric pressure. This added pressure forces more air into the cylinders, helping the engine burn more fuel and produce more power. The 0.8 to 0.9 bar boost level gives the engine a significant performance boost without requiring the complexity of a turbocharger. Intercooler, liquid-to-air intercooler. The intercooler helps reduce the temperature of the compressed air coming out of the supercharger. Cool air is denser, meaning it has more oxygen molecules for combustion, which leads to better performance and efficiency. Fuel and ignition system. Fuel injection system, electronic fuel injection, EFI. The C230 compressor uses an advanced electronic fuel injection system to precisely control the amount of fuel injected into the combustion chambers. This results in efficient combustion, better fuel economy, and fewer emissions. Each cylinder has an individual injector that sprays fuel directly into the intake port, ensuring the optimal air-fuel mixture. Fuel management system, Bosch Motronic Me 2.1 or Me 2.8. The Bosch Motronic system is a fully integrated engine management system that combines the control of fuel injection, ignition timing, and supercharger boost. The system monitors parameters like engine speed, load, and temperature to adjust the fuel injection and ignition timing, ensuring optimal engine performance and efficiency. Ignition system, coil on plug ignition, COP. The coil on plug ignition system eliminates the need for traditional spark plug wires by placing the ignition coil directly on each spark plug. This system provides stronger, more reliable spark delivery, leading to better combustion and increased engine efficiency. Cooling system. Radiator, front-mounted aluminum radiator. The radiator cools the engine coolant by transferring heat from the coolant to the surrounding air. The front-mounted position maximizes airflow through the radiator to aid in heat dissipation, keeping the engine at an optimal temperature. Cooling fan, electric or belt-driven fan. The cooling fan draws air through the radiator when the vehicle is idling or at low speeds to improve cooling efficiency. In some models, the fan is electric and operates based on temperature sensors, while others use a mechanical fan driven by a belt connected to the engine. Thermostat, regulates coolant temperature. The thermostat controls the flow of coolant to the radiator, ensuring that the engine reaches and maintains an optimal operating temperature. If the engine is too cold, it restricts the flow of coolant. If it's too hot, it allows more coolant to flow to reduce the temperature. Oil cooler, integrated oil cooler for engine oil. The oil cooler helps maintain the engine oil at the correct temperature, preventing it from becoming too hot and losing its viscosity. It is essential for supercharged engines, as the extra heat generated requires proper oil cooling to maintain performance and longevity. Lubrication system. Oil pump, gear-driven oil pump. The oil pump circulates engine oil throughout the engine to lubricate moving parts, reducing friction and heat buildup. The gear-driven mechanism ensures reliable operation at varying engine speeds. Oil filter, spin-on type filter. The oil filter removes impurities and particles from the engine oil, preventing engine damage. The spin-on filter is easy to replace during regular oil changes and ensures clean oil circulation throughout the engine. Oil capacity, 4.5 to 5.0 liters, depending on model year. The engine oil capacity is the total volume of oil required for the lubrication system. Regular oil changes are necessary to maintain engine health, especially in a supercharged engine that operates under more stress. Valve timing and timing mechanism. Timing chain, connects the crankshaft and cams Hafts. The timing chain synchronizes the rotation of the crankshaft and cams Hafts, ensuring that the intake and exhaust valves open and close at the correct times during the engine cycle. The timing chain is durable and designed to last for the engine's lifespan. Variable valve timing, VVT optimizes intake and exhaust valve timing. Variable valve timing adjusts the timing of the valve openings based on engine speed and load. It improves power output at high engine speeds and enhances fuel efficiency at low speeds. This is a critical feature for balancing performance and fuel economy. Exhaust system. Exhaust manifold, cast iron or stainless steel. The exhaust manifold collects exhaust gases from the engine cylinders and directs them into the exhaust pipe. The material choice ensures it can withstand the high temperatures generated during combustion. Catalytic converter, reduces emissions. The catalytic converter converts harmful emissions like carbon monoxide, hydrocarbons, and nitrogen oxides into less harmful substances, carbon dioxide, water, and nitrogen. This is crucial for meeting modern emission standards. Exhaust system layout, dual exhaust pipes. The dual exhaust system reduces exhaust back pressure, which can increase engine power. The system directs exhaust gases away from the engine more efficiently, aiding in performance and engine longevity. 8 transmission and drivetrain. Transmission options, 5-speed manual or 5-speed automatic, 722.6 series. The 5-speed manual transmission offers greater driver control over the vehicle's performance, while the 5-speed automatic transmission, with a torque converter, is more convenient and smoother for daily driving. The 722.6 series automatic transmission is known for its smooth shifting and durability. Clutch and flywheel, mechanical engagement and disengagement. The clutch system engages and disengages the engine from the transmission to allow smooth gear changes. The flywheel stores rotational energy from the engine, helping to maintain smooth operation and reduce engine vibrations. Differential, rear-wheel drive layout. The rear-wheel drive layout transmits power from the engine to the rear wheels via the differential. The differential allows the wheels to rotate at different speeds, especially when turning, ensuring stability and better handling. 9 Electronic Control Unit, ECU. Engine Control Module, ECM Bosch Motronic Me 2.1/2.8. The ECM is the brain of the engine, controlling fuel injection, ignition timing, and other essential systems. It receives input from various sensors, such as the crankshaft position sensor, oxygen sensors, and intake air temperature sensor, to optimize engine performance. Extensive look at the components that make up the Mercedes-Benz C230 compressor engine. The engine is a highly integrated system that relies on various components working together harmoniously for optimal performance. The supercharged inline-4 engine design allows the car to achieve both performance and efficiency, while its advanced fuel injection, cooling, and lubrication systems ensure that the engine runs smoothly under different driving conditions. Understanding the schematics and function of each component is critical for maintenance, troubleshooting, and performance tuning. Pre-procedure checklist. Before starting the process, make sure you have the proper tools and equipment, as well as a safe workspace. Additionally, ensure you understand the vehicle systems in detail to avoid damaging any components. Tools and equipment. You will need several essential tools, including engine hoist or crane, used to support and lift the engine out of the engine bay. Jack and jack stands, for lifting and securing the vehicle. Socket set, metric for removing bolts and fasteners. Wrench set, for loosening stubborn or hard to reach bolts. Torque wrench, ensures that bolts are tightened to the manufacturer's specifications. Screwdrivers and pliers, for disconnecting clips, fasteners, and sensors. Drip pans, to catch fluids as you drain them from the car. Engine stand, a platform for mounting the engine to disassemble it safely. Safety precautions. Always disconnect the negative terminal of the battery first to prevent electrical shorts. Wear gloves, safety glasses, and other appropriate PPE to protect yourself. Make sure the car is on a level surface and use jack stands. Never rely solely on a jack for support preparation and vehicle lifting. Before beginning the engine removal, ensure the car is secure, and all necessary fluids are drained to prevent leaks and spills. Park and secure the car. Place the vehicle on a flat, level surface and engage the parking brake to prevent movement. Raise the front of the car using a jack and secure it with jack stands beneath the frame rails, ensuring stability throughout the procedure. Disconnect the battery. Disconnect the negative terminal of the battery to prevent electrical shorts or accidental starts while working on the vehicle. Draining fluids. Draining fluids is an essential step as you will need to remove various components to access the engine, and fluid leaks can damage both the environment and your tools. Drain the engine oil. Position a drain pan under the oil pan and remove the oil drain plug. Allow all the oil to drain completely before replacing the drain plug to prevent spills. Drain the coolant. Remove the radiator drain plug or disconnect the lower radiator hose to allow the coolant to drain from the engine. Be cautious as coolant can be toxic and should be disposed of properly. Drain transmission fluid, if applicable. If you are removing the engine and transmission together, it is essential to drain the transmission fluid. Locate the transmission drain plug and remove it, allowing the fluid to drain completely. Remove external components. Now, we begin the process of removing external components, which will allow better access to the engine. Each of these parts plays a critical role in the engine's operation, and you'll need to detach them carefully. Air intake system. The air intake system consists of the air filter, intake ducts, and sensors such as the mass airflow (MAF) sensor. These components provide clean, filtered air to the engine for combustion. Disconnect the air intake hoses, remove the air filter housing, and unplug any sensors connected to the intake system. Throttle body. The throttle body controls the amount of air entering the engine by regulating airflow as per the driver's accelerator input. Disconnect the throttle body's wiring harness and any vacuum lines connected to it. Then, unbolt the throttle body from the intake manifold and set it aside. Exhaust system. The exhaust system channels gases from the combustion process out of the engine. Disconnect the exhaust manifold from the engine block, then separate the exhaust pipes from the engine. This will involve removing bolts and disconnecting any sensors like oxygen sensors. Cooling system. The cooling system includes the radiator, water pump, hoses, and the thermostat, all of which regulate engine temperature. Disconnect the radiator hoses, upper and lower, from the engine block, and remove the coolant hoses running to other components such as the heater core or transmission cooler. Set aside the radiator if necessary. Serpentine belts and pulleys. The serpentine belt drives essential components like the alternator, power steering pump, and air conditioning compressor. Use a wrench to relieve the tension on the serpentine belt and remove it. If the engine has multiple belts, for instance, a dedicated belt for the AC compressor, remove them as well. Power steering and A/C lines, if applicable. If the vehicle has power steering or air conditioning, disconnect the power steering lines from the pump and cap them to avoid leaks. For air conditioning, ensure the refrigerant is evacuated properly. This may require professional equipment before disconnecting the lines. Disconnect engine electrical connections. The engine is connected to the vehicle's electrical system, including sensors, wiring harnesses, and fuel systems. These must be carefully disconnected to avoid damage. Unplug wiring harnesses. Disconnect the electrical connections from the engine's wiring harness. This includes sensors for things like the oxygen sensor, crankshaft position sensor, fuel injectors, ignition coils, and the throttle position sensor. Take care to label these connections if you are unfamiliar with their placements. Fuel system. The fuel system is connected to the engine and provides fuel to the injectors. Relieve the fuel pressure, using a pressure relief tool if necessary, then disconnect the fuel lines. Ensure the fuel tank is not pressurized before disconnecting. Remove engine mounts. The engine is supported by mounts that connect it to the car's frame. These must be removed before you can lift the engine out of the bay. Locate and unbolt engine mounts. The engine is supported by 3 main mounts, front, rear, and sometimes a side mount. Locate the engine mount bolts and carefully unbolt them, leaving 1 or 2 bolts attached slightly to prevent the engine from falling. Support the engine. Use an engine hoist or crane to support the weight of the engine before fully removing the mounts. Remove the transmission, optional. In some cases, the engine will need to be removed with the transmission attached. The transmission connects to the engine through the bell housing, and this step will require extra care. Disconnect transmission from engine. Remove the bolts that connect the transmission bell housing to the engine block. Then, separate the transmission from the engine by carefully pulling it away. Be mindful of the torque converter, which may come loose if not properly supported. Lift the engine out. After everything has been disconnected, it's time to lift the engine out of the bay. Attach the hoist to the engine. Attach the engine hoist to the engine's lifting points, ensuring they are secure. Lift and remove the engine. Slowly lift the engine out of the engine bay, carefully maneuvering it to avoid damaging any components. Keep a close eye on any remaining connections that may be caught. Place the engine on an engine stand. Once removed, place the engine on an engine stand. This allows for easy disassembly, inspection, and repair. Repair process. Disassembly. Engine disassembly involves carefully removing components that make up the engine assembly. Each part plays a specific role in the engine's function. Cylinder head. The cylinder head covers the top of the engine block and contains the intake and exhaust valves, cams haft, and timing mechanism. Removing the cylinder head allows access to internal engine components such as the pistons and valves. Timing mechanism. The timing belt or chain synchronizes the engine's cams haft and crankshaft, ensuring the valves open and close at the proper time. You'll need to remove the timing chain/belt and related components. Pistons, crankshaft, and connecting rods. The pistons convert the energy from combustion into mechanical motion. If necessary, remove the pistons and inspect them, checking for wear. The crankshaft converts the linear motion of the pistons into rotational motion, so it's crucial to inspect it for any damage. Reassembly and reinstallation. 1. Reassemble the engine. Reassembly involves returning all components to their proper place. Install gaskets and seals. Replace any worn gaskets and seals with new ones, ensuring that they are placed correctly to prevent leaks once the engine is reassembled. Torque specifications. Follow the service manual's torque specifications for tightening bolts and fasteners. Over-tightening can lead to component damage, while under-tightening may lead to leaks or failures. Reinstall the engine. Once the engine is repaired, it's time to reinstall it. Lower the engine into the bay. Carefully lower the engine back into the engine bay, aligning the engine with the mounts and transmission, if applicable. Reconnect components. Reinstall the components that were removed earlier, such as the intake system, exhaust system, and cooling hoses. Make sure all connections are secure. Final checks and cleanup. Check for oil leaks. Before starting the engine, double check for any fluid leaks, particularly from the oil, coolant, and fuel systems. Test the engine. Start the engine and let it idle. Listen for unusual noises, check for smooth operation, and monitor fluid levels. Road test. Take the car for a short test drive to ensure everything is functioning correctly and there are no issues with engine performance or handling. Clean the work area. Dispose of any used fluids properly, and clean the workspace to ensure it's safe and tidy. Engine components. Cylinder block, the main structure that houses the pistons and cylinders. It provides the foundation for the engine and supports the other components. The M111.981 engine block is made of cast iron, which offers durability and heat resistance. Pistons move up and down within the cylinders to create power. They transfer the force from the combustion process to the crankshaft. The pistons in the M111.981 are designed to withstand high pressures and temperatures. Crankshaft converts the linear motion of the pistons into rotational motion. This rotational motion is what ultimately drives the wheels of the car. The crankshaft in the M111.981 is precision engineered for smooth operation. Cams haft controls the opening and closing of the valves. It ensures that the intake and exhaust valves open and close at the right times for optimal engine performance. The M111.981 engine features dual overhead cams hafts, DOHC, for precise valve timing. Valves regulate the flow of air and fuel into the engine and exhaust out of the engine. They open and close to allow the intake of air and fuel and the expulsion of exhaust gases. The M111.981 engine has 16 valves, 4 per cylinder, for efficient airflow. Supercharger forces more air into the engine to increase power output. It compresses the air before it enters the combustion chamber, allowing for more fuel to be burned and more power to be generated. The M111.981 engine uses a supercharger to boost its performance. Fuel injectors deliver fuel to the engine cylinders. They spray fuel into the combustion chamber in a fine mist for efficient combustion. The M111.981 engine is equipped with high-precision fuel injectors controlled by the engine management system. Spark plugs ignite the air-fuel mixture in the cylinders to create combustion. They produce a small, controlled spark to start the combustion process. The M111.981 engine uses advanced spark plugs for reliable ignition. Timing chains ensure the cams haft and crankshaft rotate in sync. They maintain the precise timing needed for the engine to run smoothly. The timing chains in the M111.981 engine are designed for durability and longevity. Oil pump circulates oil to lubricate the engine components. It ensures that all moving parts are properly lubricated to reduce friction and wear. The oil pump in the M111.981 engine is efficient and reliable. Cylinder head contains the valves, spark plugs, and fuel injectors. It sits on top of the cylinder block and forms the combustion chamber. The cylinder head in the M111.981 engine is made of aluminum alloy for lightweight and efficient operation. Valve train includes the cams hafts, lifters, and rocker arms. It is responsible for the operation of the valves. The valve train in the M111.981 engine is designed for precise valve control and minimal maintenance. Oil filter removes contaminants from the engine oil. It helps keep the oil clean and ensures the engine stays lubricated. The oil filter in the M111.981 engine is high quality and easy to replace. Coolant system includes the radiator, water pump, and thermostat to manage engine temperature. It prevents the engine from overheating by circulating coolant. The coolant system in the M111.981 engine is efficient and reliable. Exhaust system channels exhaust gases away from the engine. It includes components like the exhaust manifold, catalytic converter, and muffler. The exhaust system in the M111.981 engine is designed to reduce emissions and noise. Camshafts and timing chains controls the timing of the engine's valves and ensures synchronization. Proper timing is crucial for engine efficiency and performance. The camshafts and timing chains in the M111.981 engine are precision engineered for optimal operation. Cylinder head and valve train houses the valves, camshafts, and rocker arms. It plays a key role in the combustion process and overall engine operation. The cylinder head and valve train in the M111.981 engine are designed for high performance and durability. Oil circulation includes oil filters, oil pumps, and oil pans to ensure proper lubrication. Clean oil is essential for the longevity of the engine. The oil circulation system in the M111.981 engine is efficient and reliable. Pistons and cylinders, the core components where combustion occurs. They are the heart of the engine's power generation. The pistons and cylinders in the M111.981 engine are designed for high efficiency and durability. Turbochargers and superchargers enhances engine performance by forcing more air into the combustion chamber. They boost the engine's power output. The supercharger in the M111.981 engine is designed for optimal performance. Engine tools includes diagnostic tools, valve adjustment tools, and engine support bars for maintenance and repair. These tools help keep the engine in top condition. The M111.981 engine is designed for ease of maintenance and repair. Main engine components, crankshaft sensors, crankshaft seals, and crankshaft bearings for smooth operation. These components ensure the engine runs without issues. The main engine components in the M111.981 engine are precision engineered for reliability. Oil circulation, oil change kits, oil filters, and oil pumps to maintain lubrication. Regular oil changes are vital for engine health. The oil circulation system in the M111.981 engine is designed for easy maintenance. Pistons and cylinders, connecting rods, pistons, and cylinder liners for efficient power generation. They work together to produce power. The pistons and cylinders in the M111.981 engine are designed for high performance. Engine rebuilding kits includes gasket sets, sealants, and assembly loops for engine rebuilds. These kits are essential for major engine repairs. The M111.981 engine is designed for ease of rebuilding and repair. Turbos and superchargers, turbochargers, intercoolers, and superchargers for enhanced performance. They improve the engine's efficiency and power. The supercharger in the M111.981 engine is designed for optimal performance. In the heart of the mechanical beast lies an engine waiting to be freed. The M111.981, with all its might, must be carefully unseated indeed. To embark on this journey, precision is key, unleashing the power, setting the motor free. Begin with safety, disconnect the charge, the battery's lifeline, we must discharge. Drain the fluids, each drop must be spared, oil, coolant, transmission their release declared. Remove the obstructions, clear the path wide, the front bumper, the panels, set them aside. Electrical lifelines, now to untether, harness and connectors, they must be severed. Engine's accessories, one by one fall, alternator, starter motor, heed the call. Exhaust system untangled, freed from its hold, manifold, and converters, their stories unfold. Cooling components next in the line, radiator, water pump, they intertwine. Coolant's essence, drained to the last, thermostat and hoses, their duties surpassed. Engine mounts, the guardians of place, support the heart with a gentle grace. Jack stands and hoists, lend their aid, the mounts relinquished, their duty delayed. Transmissions embrace, if it must part, unbolt the connections, from end to start. Torque converter bolts, release their might, engine and transmission, uncoupled in sight. The engine's now ready, to rise from its keep, an engine crane beckons, its promise we reap. Gently and steadily, lift the machine, maneuvering carefully, precision seen. Out from the bay, the heart is now free, set on a surface, its journey complete. Inspect the remains, the bay now bare, clean, and prepare, for what's to come there. Each step a verse, in this mechanical rhyme, the M111.981, freed with time. Precision and patience, the key to success, an engine's removal, with finesse expressed.